Alright, now we're going to talk about resistors in parallel. Last time we talked about them in series, but now we're going to talk about them in parallel. And parallel really just means that the circuit has multiple pathways for the current to get from one end of the battery through the circuit and back to the battery. Remembering that it starts at one terminal and then goes to the other. So for example, it starts at this terminal of the battery and it goes through, and it can make a decision. It can either go up here to the top, it can go through the middle, or it can come out down here to the bottom. So then after it gets over here, if it comes to the bottom, then it can go back to the battery from there. So that would be one pathway. It could have gone straight through the middle and then back to the battery. So that's a second pathway. It could have gone up here to the top, through, and then back to the battery. So that's a third pathway. So that makes this parallel instead. So this picture right here, same thought process. We have these batteries right here in parallel with each other. So they have different pathways to go through when we look at it like that. Then this one, it could go from here up through this light and then back. Okay, or it could go from here up through this light and back here and skip this one completely. Okay, then if we look at it as a schematic here, you can do it this way, where it goes out of the positive and back to the negative, and that would be one loop. And then the other loop would be out of the positive up through this resistor and back. Okay, now I didn't mention this before, but if you think about Christmas lights, and you think about how Christmas lights, sometimes if one bulb goes out, they all go out. Well, that is a series circuit. And those are the kind of Christmas lights that I had when I was a kid. Hated them because I was the one that had to go through and find the lights that burn out. So once you found that one, then the whole thing would light up again. I love these kind of lights where they're in parallel, which is what my Christmas tree now is because if one light goes out, there's another pathway for it to get back, so the whole thing doesn't go out. So this is what most of your Christmas lights are now versus what they used to be. Depends on which ones you buy, but this is what most of them are. This is also what most of your circuits in your house are. Now, some of your rooms are in series, and so if one plug goes out, like a whole line of them will go out, but otherwise, most of them are going to be in parallel. So like one room is wired separately from another room, so if something happens in that one room, it doesn't make the whole house stop working. So that would be in parallel because there's another pathway. So rules for parallel circuits. Just like we had rules for series circuits, we have rules for parallel circuits. So each resistor provides a new path for electrons to flow. So the total current is actually the sum of each of the currents this time. Because what's going to happen is the voltage is going to be given to every single one. And so since the voltage is going to be given differently, then they're going to be able to have different currents. So this is different than last time. This is more like what the voltage was in our series circuit. Is now the same for the current in our parallel. Now, equivalent resistance, every time we add a resistor, when we have a parallel circuit, we actually cause the overall resistance to go down. Okay? And that's why if you plug too many things in to a parallel circuit, it'll cause it to short circuit and the whole circuit will stop working. That happens over at the pool a lot. Sometimes they'll plug in too many hair dryers and straighteners at once, and then all of a sudden nothing works, and that's because they've lowered the resistance too much. Okay? So that's important to realize, is that each new resistor decreases the overall resistance. But this formula is on your formula chart, as was the other one for series. But it is really 1 over R plus 1 over R plus 1 over R. So you always do the inverse of each one of them. I kind of like to write this one differently. And I like to write it like this instead, where you do 1 over R1 plus 1 over R2 plus 1 over R3, so on and so forth, that you just take all of this to the -1 power. that's where you'll be able to solve for that resistance and not forget to flip it at the very end. So I kind of I like to write that one a little bit differently. So you might want to make note of that in your notes. Now the voltage drop across each branch of the parallel circuit is the same as the total voltage. So whatever the battery has, that's what voltage every single branch gets. And so this is going to be more like what we had for current in a series circuit, now is for voltage in a parallel. So what you need to make sure you draw lines or stars around is that in parallel, voltage stays the same everywhere, okay? And in series, it was current stays the same everywhere. So make sure that if you look at the posters around the room, it says that almost on every single one because that's such a big topic, all right? So again, we can pause this, let you get all of it written down because I know you were trying to talk and listen at the same time, or write and listen at the same time, and sometimes that doesn't work. So if you need to just have it pause so you can write, do that. All right, so now let's talk about an example. We have a 5 ohm resistor and a 10 ohm resistor that are wired in parallel to a 6-volt battery. So I highly recommend drawing this schematic on your paper, and then we're going to label it. This is going to be our 6-volt battery, and then this is going to be our 5 ohm resistor because it's R1, and this is going to be our 10 ohm resistor because it's R2. Our current moves out of the positive and into the negative because remember it was determined on a positive test charge, so that's how the conventional current moves, okay? What is the equivalent resistance? So that's where we're looking for the total R value. So if that's the case, then we're going to say our 1 over R, so 1 over R1 plus our 1 over R2, and then this is what I recommended taking it to the -1 power. That would just equal our RT then, okay? So when you do that, you should end up with an answer that's 1.33 ohms. Make sure everybody can do this in your calculator because this is going to be a huge part of this next test. And you really do need to make sure you know how to do this in your calculator, okay? So again, you can do 1 over 5 plus 1 over 10 and then hit the enter button and do 1 divided by the answer, or you can do 1 over 5 plus 1 over 10 and then hit the hit enter, but then take it to the power button, your caret button, and then do the -1. So either way works. You just have to decide what you like best. Okay, now I also want to know what the current is through each resistor. So current can be different for a parallel circuit. So current is found by using Ohm's law of voltage divided by resistance. Each branch gets the total voltage, so the voltage would be 6 volts divided by my first resistor, which would be R1, so divided by 5, which would give me a current of 1.2 amps. Now then I could do it for the second one as well, which would then be 6 volts again, divided by my second resistor, which is 10 ohms, which is going to give me 0.6 amps. Now I could find the total current by adding the two together, and that would be my 1.8 amps. But I could also see if that works if I take the total voltage divided by the total resistance, because the total voltage was 6 volts and my total resistance was 3.33 ohms. So if I do that, I get an answer of, and let me move this little screen, this little gray screen, of 1.8 amps. Wow, when I added those two together, I also got 1.8 amps. So there's lots of ways to check yourself when you're doing circuit calculations to make sure that things are adding up right. So just make sure you're following the rules. So really just pay attention to those rules, okay? Again, today you're going to be working on some worksheets that are parallel circuits, and you can work together. Answers are posted in the back of the room. But again, I will remind you, 1, you need to show your work, and 2, you're not allowed to work in the back. Remember, you can just go check your answers, and that you shouldn't be taking any writing utensils or anything else, okay? That's it. You guys have fun. Be good. See you soon.